Question 1.5 asks us for which values of p will basically give us unequal roots for this formula. So we've got to find the values of p that will give us unequal roots. So let's have a look at our nature of roots formulas. So the nature of roots formula is b squared minus 4ac. A, b, and c are representative of the coefficients of x squared, x, and no x respectively. So if I want real roots, I model it to be bigger than or equal to 0. If I want real and unequal roots, I model it to just be bigger than 0. And if I want real and equal roots, I make the discriminant equal 0. And if I want non-real roots, I make my discriminant less than 0. We are going to be heading down this path, the unequal roots. The question specified they want unequal roots. So let's get rid of the other equations. Okay, but we have a bit of a problem. We need standard form so that we can get A, B, and C. So I'm going to grab this equation quickly. And to get this in standard form, I'm going to move the P over next to the 3 here, and it's going to become plus P. And that's officially all it takes to get it in standard form. Now the coefficient of x squared is my A value. And the coefficient of x forms my b value. And everything that does not have an x forms my c value. Now that we've got standard form out the way, we're going to chuck a, b, and c into this formula, and then we're going to see where it takes us. We're going to strap on for the ride, my bro. So b is 4, so I'm going to change this b to 4. And then a is negative 2, so I'm going to change this a to negative 2. And c is this mess over here, so I'm going to change c to this, but don't forget brackets, it must be inside a bracket. Once our substitution has been made, we are going to solve for p. So 4 squared is 16. Minus 4 times minus 2 will give me plus 8. And I'm going to leave the rest of it for now. Now I'm going to distribute this plus 8 into the bracket. Alright, plus 8 times negative 3. A positive times a minus is a minus. 8 times 3 is 24. And 8 times p will just give me plus 8p. And nothing will change with the rest of the inequality. This will still point in the same direction, and we've still got our crispy little kanda over there, bro. Right, let's start simplifying this. 16 minus 24, triple check with your calculator. It's going to be negative 8. And then we're going to shine this negative 8 over to that side. Just remember, you change the sign when you do that. So if you're going over the inequality symbol, it's going to change sign to positive 8. Now I need to get rid of this 8 in front of p, so I divide both sides by 8 to get rid of it. Okay, and then these 8s over here are gonna bro, they cancel with one another, leaving you with just a p on this side, and 8 divided by 8 is simply just 1. So whenever p is bigger than 1, we're going to get unequal roots for this quadratic formula, or unequal x-intercepts if you want to see it that way. So let's have a look where the 4 marks come from. We get 1 mark for the substitution into the discriminant formula, 1 mark for the condition of making the discriminant bigger than 0. 3rd mark comes from the correct delta expression, and the 4th mark comes from the correct final answer. Okay, welcome to your challenge round. So for which values of p will this equation have roots that are both positive? To start this off, I'm going to divide everything by negative 1 so that I get a positive p here. It's much easier to work with positive p rather than negative p. And in summary, what that does is it changes the signs of everything. So this minus 2x squared became positive 2x squared. The plus 4x became minus 4x, etc., etc. Now, to help you understand this question, I'm going to draw this parabola. because the number in front of x squared is positive, it's going to be a happy face. And then I'm going to show you around this parabola a little bit. This plus 3 will represent the y-intercept of the parabola. And because I have a negative b value, I know that the turning point of the parabola sits on this side of the y-axis. So it's to the right of the y-axis. And then from the previous question, we discovered if p is bigger than 1, we are going to get unequal roots. So how you should picture this is p is a horizontal line. And if I place that horizontal line anywhere above 1, I'm going to get unequal roots. So it stands to reason if I place it on 1, I'll get equal roots. So the parabola won't actually look like this. Its bum is going to sit here. Its turning point will sit on this line. So it will look more so like this. So anytime p is bigger than 1, so let me show you. If I draw the horizontal line here, then the roots are unequal. I get unequal x values for the roots. And the roots are representative of where this horizontal line touches this parabola. And that happens all the time when p is bigger than 1. So if I put the horizontal line back down here on the turning point, then what I can do is draw that horizontal line anywhere in between 1 and 3, and it's going to give me positive roots. And just to illustrate that a little bit better, let's say p was 2, and I draw it there, then we can see that these x values are positive x values, which means I'm going to get positive roots. If I had to put the vertical line up here past 3, then what's going to happen is one of my roots will actually give me a negative x value, and the other root will give me a positive x value. So I can't put p above 3. That will be true no matter how far I move the horizontal line upwards. So in summary, I want p to be anywhere in between 3 and 1. And I'll state that like this. P must be smaller than 3, but at the same time bigger than 1. Yes, this question was some other type of nasty stuff, my bro. And then to quickly have a look at your 2 marks, any valid method gets you your 2 marks here. You've got wiggle room to be a bit creative with the solution. And then in question 1.6, we need to show that this monstrous equation has no real roots for p and q is an element of real numbers and q cannot equal 0. So let's walk through how we're going to do this. So we are going to have to sub a, b, and c into the nature of roots formula. But there's a problem. This thing is not in standard form quite yet. So that's going to be mission number 1, is to get this equation into standard form. So let's go ahead and do that. So after I've grabbed the equation, I'm going to move both of these terms over to that side of the equal sign so that everything equals 0. And remember, we want the right order. We want x squared first. We want the one with x in the middle. And the one that does not have an x, we want it at the end. Okay, so this is going to stay in front. When I move this over, it changes from a minus to a plus. And then we're going to move this okie over all the way to the end here. And he's a minus over here, so if I move him over the equal sign, he's going to become plus q squared. And as always, we have the equals kinda at the end, my bro. Yeah, now I can extract my a, b, and c values. The coefficient of x squared is a, so p squared plus 1 is my a value. And the coefficient of x is my b value, so 2pq is my b value. And lastly, everything that does not have an x is my c value. And once that's out the way, we're going to sub those guys into the discriminant formula. Now when you sub into the discriminant formula, there should be no x's there. So we do not take the x squared or the x. They disappear when we go into the step. Right, so I'm going to replace b with 2pq inside a set of brackets. And then I have the minus 4, minus 4. I'm going to replace a with p squared plus 1 inside a set of brackets. Just remember, brackets bless your life, my bro. And then one last thing needs to be substituted. We need the c value at the end here. So I'm going to replace the c with q squared, and for comfort's sake, I'm going to use brackets, my bro. Okay, now we're going to start to simplify this guy. So I'm going to shower the power in here. 2 squared is 4. Shower it to the p and I get p squared. Shower it to the q and I get q squared. So it's 4 p squared q squared. And just for interest's sake, I could have written the bracket twice as well. That works. 2 times 2 will give me that 4. P times P will give me that P squared. And Q times Q, you guessed it, gives me Q squared, boss. Okay, and then over here, I'm just going to distribute one thing at a time. So let's get that Q squared inside there. Okay, and then Q squared times P squared is just P squared Q squared. And Q squared times 1 is just plus Q squared. Now that that's done, I'm going to distribute this negative 4 into that bracket, and then I've officially got rid of all the brackets. Okay, so if I take the minus 4 and distribute it to this first term, minus 4 times p squared q squared is just minus 4 p squared q squared. You just like glue it on. Same thing is apparent here. Minus 4 times q squared is just minus 4q squared. Alright, I'm seeing some like terms here, bro. Same variables, same exponents. And 4 minus 4 gives us the classic Kanda, my bro. So if we simplify this thing, these two terms, 4p squared q squared minus 4p squared q squared, we're gonna slap them out of here, my bro. Slap. Okay. So we just left with minus 4q squared as our discriminant. And now we're going to analyze our discriminant and jump to our conclusion. So that important algebra rule is coming back into the picture. And that rule dictates that anything squared is always positive, or it could possibly be 0. So this q squared over here will always be positive. And then also they said q can't be 0, so this will never ever be 0, it will only be positive. Now I'm taking that positive number and I'm multiplying it by negative 4. And a negative times a positive will give me a negative number, so my discriminant will always be negative. Okay, now let's see how we're going to write that up. Firstly, we've got to say q squared will always be greater than 0. And I do not put the equals to sign here because they told us it cannot equal 0. So if I multiply both of these sides by by negative 4, I'm going to get a negative. So negative 4 times q squared will always be smaller than 0, aka negative. So that successfully proves that my discriminant, which is represented by a triangle, is less than 0. So we can conclude that we have non-real roots. If we square rooting a negative number, we get non-real roots. Okay, let's have a look where the 16,000 marks come from in this painful question. Ranch, we had 1 mark for your standard form there, boss. 1 mark for your substitution, 1 mark for the simplification of your discriminant, 1 mark for the correct expression for your discriminant of minus 4q squared, and then the last mark comes from your explanation behind non-real roots. You are not going to get a mark for this conclusion because they told you that. So you get a mark for explaining how your discriminant is negative.